Today we're going to talk about the one-sample hypothesis test for a mean, a one-sample t-test. Our example is there evidence that male crickets with higher chirp rate are better at attracting the lady crickets. The name of our test is a one-sample t-test for a mean, so you still need to state that when we go through our hypothesis test. Our hypotheses are the null hypothesis is mu equals some number versus one of the following. Our alternative hypothesis is mu is greater than some number, or mu is less than some number, or mu is not equal to some number. You're going to choose one of those three based on the example. We need to still check our conditions. 1, we need to check the random sample condition. 2, we need to check the 10% condition. And then 3, we need to state the population is normal, or the sample is large enough, or the histogram or normal probability plot of sample data suggests it's plausible that the sample data are drawn from the normal population. If it is possible the sample was drawn from the normal population, we can use the t-distribution. And then here's our formula for t. X bar minus mu all over the sample standard deviation divided by the square root of n with degrees of freedom of n minus 1. Let's look at our example. The article, Well-Fed Crickets Bowl Maidens Over, reported that female field crickets are attracted to males that have high chirp rates and hypothesized that chirp rate is relative to nutritional status. The usual chirp rate for male crickets was reported to vary around a mean of 60 chirps per second. To investigate whether chirp rate was related to nutritional status, investigators fed male crickets a high-protein diet for 8 days, after which chirp rate was measured. The mean chirp rate for crickets on the high-protein diet was reported to be 109 chirps per second. Is this convincing evidence that the mean chirp rate for crickets on a high-protein diet is greater than 60, which would imply an advantage in attracting the ladies? Suppose the sample size and the sample standard deviation are n equals 32 and s equals 40. We test the relevant hypothesis with alpha equals 0.01. So we're going to go through the steps to do this. First, we need to state the name of our hypothesis test. And this is a one-sample t-test for a mean. Then we need to state what mu is. Mu is the mean chirp rate for male crickets. State our null hypothesis. Mu equals 60 chirps per minute. And our alternative hypothesis would be mu is greater than 60 chirps per minute. Our evidence for our null hypothesis is x bar equals 109, which is greater than 60. So now we need to check our conditions. So we weren't told this is a random sample of male crickets, so we must assume this sample represents the population. N equals 32, which is greater than 30. So we have a large enough sample. And N equals 32 is less than 10% of all male crickets. Now we need to find T. T equals X bar minus mu, all over our sample standard deviation, over the square root of N. So that would be 109 minus 60, all over 40, divided by the square root of 32. You can go ahead in your calculator and put this information in your t-test using stats, and you have your mu, x bar, sample standard deviation, and n. And when you put that in, this will give you your t value of 6.93. They told us that alpha equals 0.01, and we know our degrees of freedom is 32 minus 1, which equals 31. Our p-value from our test equals 4.497 times 10 to the negative 8th. So that's about 0. So our p-value is less than alpha because our p-value is 4.497 times 10 to the negative 8th, which is less than 0.01. So we reject our null hypothesis. Our sample provides convincing evidence to suggest mean chirp rate for male crickets on a high protein diet is greater than 60 chirps per minute.